Hello friends, today we will be looking at basics of airfoil theory as a part of renewable energy sources subject which comes in B.Tech third year and fourth year. When it comes to airfoil, when we need to look at the introduction part of this, okay, it is a basic part of an aircraft. It is used in many parts of an aircraft as it is basically a shape which is used to produce a lift. You can see here the structure of the airfoil. We'll be looking at the different parts and nomenclature of this airfoil in detail in upcoming slides. You can observe the airfoil shape here. It is a shape of the wing. Actually, it is a shape of the wing or blade which is used in propeller. Propeller means something which is rotating, rotor, and which may be used in wings, fuselage, nothing but it's a entire body of the aircraft, vertical and horizontal stabilizers, because aeroplane has to be in stable position. It should not vibrate much, it should not turbulent much in the space to produce the lift. When you look at this diagram, there will be two forces which are acting on the aeroplane: lift and drag. Lift is the mechanical force which is generated by a solid object moving through a fluid. You can see at the right part of the slide, it is a force that is directly opposing the weight of the aeroplane. You can see in the diagram, lift is opposite, equal and opposite to the weight. Weight is acting downward, but lift is acting upward. Lift is generated by every part of the aeroplane because weight of all the parts together gives us the weight of the entire aeroplane. You can see drag, which is acting backward. Thrust is acting in the front direction. Thrust is nothing but a force. Okay, it is driving the aeroplane in a forward direction. Drag is the opposite force to the thrust. And you can see when it comes to this lift, most of the lift on a normal airliner is generated by the wings. Since this is the mechanical force which is trying to lift the vehicle, the meaning of this is uh, it makes the airplane to stay in the air. It has to be lifted in the air. It has to be in the air. So that's why wings plays major role to keep up the airplane in the air. Of course, when it comes to the shape of this airfoil, it is the shape of a fish, as it was made by getting the inspiration of a fish swimming against the heavy flow of the water. Our aircraft will be moving in a air, but when it comes to fish, it will be moving across the heavy flow of the water. You can see here, this is the fish, and this is the structure of the aerofoil which resembles the shape of the fish. When it comes to parts, okay, we will be having two parts, main parts of this airfoil. One is leading edge, another one is trailing edge. Of course, leading edge is the front portion, front part of the airfoil. Trailing edge is the back part. To remember this, sometimes we may get confused. Trailing edge and leading edge. Leader, okay, leader, nothing but leading. It will be at the front. Leader will be at the front, like that. So leading edge is the front part of the airfoil, which comes in contact with the air first. Trailing edge, trail, or you can say in just for an example, I'm saying tail. Tail will be at the back side. So tail edge means trailing edge. It will be at the back side of this airfoil. Let's look at the leading edge in detail. Of course, it is a frontal smooth part of the aeroplane. As you can see in the previous slide, it is a smooth part of the aeroplane. As air is coming from the front direction, therefore, this part means leading edge will meet the air first. It is designed in such a way that it is designed according to the functioning of the aeroplane, according to the function of the aeroplane. So aeroplane need to achieve a more speed. Next, when it comes to trailing edge, of course, is a terminating part of the aeroplane. It is the end part of the airfoil. So it is designed to smoothen the flow of the air at the end. It has to smoothen the flow of the air at the end. So we can avoid the turbulence of the airflow. Because due to the turbulence of the airflow, there may be a vibration in the airplane. So there will be turbulence in the there will be a disturbance and turbulence in the aircraft. So to maintain the stability, the design is made as per the diagram. When it comes to this airfoil, of course, we should know the terminologies with respect to airfoil. Basic terminologies of an airfoil. First one is chord. You can look at the diagram. Okay, there is a like how we have chord in the circle in maths. How we have a chord in the circle. Here also it is an imaginary straight line joining the leading and trailing edge. You can see the chord here. It is an imaginary straight line which is joining the leading and trailing edge. MAC. It is referred as a mean aerodynamic chamber. Mean M, aerodynamic A, camber C. It is a mean aerodynamic camber. It divides the aerofoil in two equal parts. You can see here mean camber line, okay, mean aerodynamic camber, which is dividing this airfoil into two equal parts. That is very, very important here. Camber, it is maximum vertical distance. You can see it is a vertical distance between chord line and MAC line. Next, when it comes to types of airfoil, we will be having two types, symmetric and asymmetric. Of course, symmetric means like mirroring. If you mirror it, you will be getting the same same shape on both sides. Like if you cut your body vertically, both the sides will be getting same shape. So in such a way, you can see here the airfoil in which MAC and chord lies on one another. Since it has to be cut equally, it has to be divided equally. So this chord line and mean camber line will overlap. So there will be no camber here actually. So that's why we will be getting symmetric between top and bottom surface of the aeroplane, aerofoil. Next comes asymmetric. Of course, symmetric means same. Both the shapes, both the we can say both the parts are same. Here it is not same. It is not getting divided equally. Symmetric is also known as non-cambered airfoil. Asymmetric is known as cambered opposite. When you see these two, when you compare these two, asymmetric aerofoil means cambered aerofoil will produce more lift, while non-cambered means symmetric aerofoil will provide the more speed. When we look at the numbering system, NACA aerofoil numbering system, NACA stands for National Advisory Committee for Aeronautics. So we'll be studying two types of NACA digital airfoils, NACA 4 digit and NACA 5 digit. Let's look at NACA 4 digit airfoil first. We use this system to interpret the information regarding the airfoil. So when it comes to NACA 4 digits, in that you can see the example here, you will be understanding better. Later we'll go to these points. NACA here 4 digits. So here first digit, this 4 is indicating the camber in the percent chord, 4% chord. Next second digit gives the location of the maximum camber located in the 10th of the chord, 50%. Because, okay, if you consider a symmetric one. And when it comes to last two digits, 26, this will be giving the thickness, 26% of the thickness. Next, when it comes to 5 digit aerofoil, first digit when multiplied by 0.15 gives the designed theoretical optimum lift coefficient at ideal angle of attack. Okay, it will give when we multiply this with the first digit. When we multiply first digit with 0.15, it will give the theoretical optimum lift coefficient, the value of lift required at an ideal angle of attack. What is the value of coefficient, the lift optimum value at an ideal angle of attack? Okay, at ideal angle of attack, what is the value we need for the as a uh, optimum value, as a optimum value? When it comes to second digit, when we multiply the second digit with 5, it will give the relative position as percentage of point of maximum camber along the chord from the leading edge. Third digit will indicate us whether camber is simple or reflexive. It will, if it is indicating 0, it is simple. If it is indicating 1, it is reflex type. Fourth and fifth digit, like how we had in a four-digit system, third and fourth digit was representing thickness of the foil. So here also it will be indicating the maximum thickness. Fourth and fifth digit will indicate the maximum thickness of the airfoil as the percentage of the chord. Thank you.